Good afternoon, students. In the previous class, we have discussed about an algorithm to find articulation points. There are totally 4 steps in finding articulation points for a graph. In the previous class, we have discussed about first 2 steps. The first step is we have to construct a DFS tree for the given graph, and along with that, we have to provide the DFN numbers for each node in the order of traversing the vertices in the graph. And second step is adding back edges into the DFS tree. Back edges means the edges which are present in the original graph and that are not in the DFS tree. Such edges are known as back edges. You have to add back edges into the DFS tree. Back edges are represented by the dotted lines, and direction of back edges should be from a greater DFN number to the lesser DFN number. In today's class, we will discuss about step 3 and step 4, finding articulation point for a given graph. Coming to the step 3, we have to find the low value for each and every vertex. There is a formula for finding low value. Actually, this is the definition for finding low value. By looking into the DFS tree, we can find out the low value, but it is difficult. So, apart from that, we are using a formula which is used for finding low values of the particular vertex. This is a formula used for finding low value of the vertex. Okay, see here, the formula is L of u is equal to minimum of 3 things you have to find. The first one is DFN of u, and next one is minimum of L of w, where w represents the child of the u, and next one is DFN of w, where u comma w is a back edge. So, you have to find the L values for each and every vertex in the DFS tree. Okay, so let us look at the example. See the example here. So, we have to find the L values for each and every vertices. Total 10 vertices are there in this graph. So, these are the L values. So, let us see how to find the L values. So, first to find the L values, there are 2 procedures. The first one is either you write the postfix order for the above DFS tree, or you reverse the DFN values, and in that order you have to find the L values, or you have to find the L values in the postfix order. So, better prefer postfix order. In that order only we have to find the L values. So, the postfix order for this DFS tree is 10, 9, 6, 8, 7, 5, 2, 3, 4 and 1. So, let us start finding L values. The first L of 10, we have to find the L value for 10. So, what is the formula for finding L value? Minimum of DFN of u, here the u is 10, comma, minimum of L of w, where w is child of u, and minimum of DFN of w, where u comma w is a back edge. So, let us see, is there any child for vertex 10? So, for vertex 10, there is no child in this DFS tree. So, we have kept here hyphen, and DFN of 10 is 4. So, 4 comma hyphen comma, is there any back edge from u? You check that, where u comma w is a back edge. So, from vertex 10 there is no back edge. So, keep hyphen. So, minimum of 4 comma hyphen is 4. Next, finding L value of 9. So, take the vertex 9. So, what is the DFN of 9? So, DFN of 9 is 5 comma, is there any child to the vertex 9? There is no child to the vertex 9. So, it is empty. And is there any back edge from the vertex 9? So, there is no back edge from the vertex 9. So, keep it as empty. So, therefore, minimum of 5 comma empty is equal to 5. Next, we will find L value for 6. The DFN for L6 is 8 comma, is there any child node for the vertex 6? No child node, and there is no back edge from the vertex 6. So, minimum is L value for 6 is 8. Next, coming to the finding L value for vertex 8. So vertex 8 DFN number is 10, comma, is there any child to the vertex 8? There is no child, so empty. And is there any back edge from vertex 8? Yes, there is one back edge from vertex 8, 8 to 5. So what is the DFN of W you have to find. So DFN of 5 is, sorry, 8 to 5, U comma W, W is a back edge. So DFN of 5 is, one second, wait ma.